Hey guys, welcome back to our R programming series. Today we are diving into an essential topic in data science and analytics, time series analysis in R. If you work with data that changes over time, such as sales figure, stock price, or weather data, understanding time series analysis will help you make prediction, identify trends, and uncover seasonal patterns. In this tutorial, we will cover loading and exploring a time series dataset, applying the ARIMA model, and interpreting the results. So let's get started. First, we need some libraries. The Forecast library and tseries. If you haven't, there's install in your PC, and after installing, you should call the libraries. And then, to start, we'll load a sample dataset and take an initial look to understand its structure. So for that, this is the dataset. We use here ts function to convert our data into a time series object. We specify the starting year with 2000 with a monthly frequency 12, and then we use a plot data which gives us a quick visualized representation of the data and also shows us the trends or seasonality. So let's run it and take a quick look on the results of the data. This is our data set and this is the time series data. So next, let's decompose our time series into trend, seasonal, and random components. This helps us understand the underlying pattern better. So for that, this is the following code. Just run it and make the plot, and this is the decomposition plot of the time series. This is our main data, and this is a trend, and this is a seasonal data, and this is for the random set. This breakdown helps us see if our data has consistent seasonal peaks and an underlying trends. For time series, it's crucial to check if the series is stationary or not. A stationary series has a constant mean and variance over time, which is required for model like ARIMA. And for that, this is the following code. Here we test an Augmented Dickey-Fuller test. Here the Augmented Dickey-Fuller test or adf test checks the stationary. If the p-value is less than 0.5, the series is stationary, and if it's greater than 5, the series is not stationary. So look at the results, and you are seeing here the p-value is 0.01. that means this is stationary. And if our series is not stationary, we will apply differencing to stabilize the mean, and for that, this is the following code. Just look at the results of the plot. In this step, we used diff data to apply first order differencing, which removes trends by calculating the differences between consecutive points. The resulting point should look more stable, indicating that our series is now stationary. So next, with a stationary series, we can fit an ARIMA model to capture the data's auto-regressive and moving average properties. And for that, this is the following code: auto.arima data, and just run it and print the data. And you are seeing here the coefficient and the sigma values. Here, the auto.arima function finds the best ARIMA parameter automatically. The output shows the model order, which tells us how many A are differentiating and MA moving average terms were selected. This model should best fit for the data forecasting. So now let's use our ARIMA model to forecast future values. This can help us predict what might happen in the coming months or years. For that, this is the following code. Here we use forecast function to generate prediction, and the plot shows us forecasted value along with a confidence interval. In the chart, just look at the results. In the chart, we're seeing this is our forecasted value, and if you look at the results of the forecasted values, we use here 12-month, and for that we get the 12-month forecasted values, and if we use 24-month, we will get the 24 months forecasted values, and also the trend will be changed for 24 months. Finally, we need to check if our model fits the data well by examining the residuals, and for that we need to check the residuals ARIMA model. Here, check residuals. This function, the residual point, autocorrelation point, and a p-value from the box test. The residual should resemble white noise. So let's run it and look at the results. Here we are using the residual from ARIMA, and this is a lag, and this is the residuals. This is like normal distribution. So that means our model is best fitted. In this video, we create a robust framework for analysis time-based data. I hope this guide has clarified how to conduct time series analysis in R. So that's for today. Thanks for watching. See you next. Bye bye.